welcome back. We're going to take a quick look at basic looping programs in Stata today. So these can be really kind of fun, really useful, and they can be a lifesaver in certain circumstances. So it's worth a few minutes of our time to walk through this. So first off, what is a loop, right? So it's basically just a little program that iterates over a particular placeholder, conducting a repetitive task multiple times. So it's worth noting that this is a program written in a programming language within Stata. So when you're first getting used to running regressions and doing data analysis in Stata, it's easy to forget, it's easy to overlook that there is a fairly rich programming language operating underneath all of this. So oftentimes running a quick loop within a do file is kind of our first introduction into programming within Stata, giving us an inkling of kind of the power that's there for us. So that's the basic idea, where anytime we have to do a repetitive task multiple times, instead of copying and pasting a slightly different command multiple times into a do file, or just typing out the command again and again and again, a loop can do that for us in an automated fashion. So very, very useful. And within that loop, we can generally conduct any command, any operation that Stata can do can be iterated over. So basically what we want to do in this little lesson is look at what commands are available for us within Stata to operate these loops, the general architecture of those commands, and then we'll jump into Stata and look at some quick examples. So there are three commands in Stata that are generally used to operate these loop scenarios. The first is the while command, the second the forvalues, and then the foreach command. As the name implies, the while loop will keep looping, keep doing what it's doing until a certain condition is met. That can be a really useful, slightly maybe more advanced way of operating these loops. The forvalue and the foreach do basically the same thing, except as the name implies, the forvalue iterates over numerical values. The foreach is a little bit more general. It can operate over numerical values and over things like variable names. So that's the one that we'll take a look at here. So no matter what command we're using, it's always going to follow the same structure. So where you see that foreach term, that could be while, forvalues, or foreach, and it's followed by some placeholder name. So for each thing within this given list, so it could be a variable list, a number list, and then the next line down is the command that we're going to be operating. And that can be multiple lines, but it's got to be the next line down in your command structure. And then notice that we have these braces, these brackets here, surrounding what is being iterated over, the commands that are being looped. So it's always going to look like that. And there's basically kind of those rules of operations. Lots of different things we can do, but it's got to follow that same architecture. So we got the open brace at the end of the first line, so nothing past that on that line. Then we run the commands, and then the end brace at the end. Okay, so that's the basic idea. So let's see how we can put this to work. So let's swap over into Stata. So I've got some data already loaded up here. We'll come back to that in a second. But let's just operate the simplest possible loop scenario, no data needed here. And so it's going to be, again, that foreach command. And then what we put next, we could call it anything we want. Let's say for each I. So again, that's the placeholder. I will equal 1, it'll equal 2, it'll iterate across our list. So it's going to be for each I within this list of numbers. So of numbers 1 to 10, so 1/10. And then we put our open bracket at the end. And for our little example here, let's just display those values I. So display I, and then to tell Stata that we're done with our programming, we put our little end bracket, and what we should see is a list of numbers from 1 to 10. So here's the first sticking point. where real easy to get frustrated. Notice that we have the I in the second line down surrounded by those inverted commas. So I want to make a special note here that those are the down and to the right on the left, and then down and to the left inverted columns after the placeholder, right? So just to avoid any confusion, when you look on your keyboard, those are in different places, right? So the first one is in the upper left, down and to the right. You put your placeholder value, the I, whatever you're using, and then the right inverted comma on the right-hand side of your keyboard, typically. So you've been warned, right? And then just to make sure we get the idea, that I term that we put in could be anything, right? So we could rerun this for each thing of numbers 1 to 10, open bracket, let's display thing, inverted commas. And we get the same thing. So whatever makes sense for you to put in for that placeholder that we're iterating over. Okay, so that's the basic structure and kind of get an idea of how we might apply that. But let's take a quick look at doing some kind of common loops with some actual data. So you can download this data and play along if you want. So we're using the Federal Reserve Economic Database, the FredUse command, and we're bringing in monthly U.S. unemployment rate, the federal funds rate, the 10-year Treasury rate, and then the 3-month T-bill rate. And we see these time series all come in at different points, so we've got a bunch of missing observations. We drop all those so we have a nice kind of balanced time series, and I've generated a time indicator, and then I've used the TS set so we can use leads and lags and time series operators just to see what our looping options are going to give us here. So the ways that we're going to use loops here is we can iterate over different sample restrictions, we can iterate over different variable names, and we can iterate over different lag structures within a time series regression. So let's look at an example of the sample restriction case first. So imagine we're going to run a regression of unemployment rate as a function of, say, the federal funds rate. But we want to see how stable the slope coefficient is across different time samples, right? So we want to run it over a bunch of different observations within our overall sample. So here's kind of a nifty way to do it. So let's try this. So let's go for each I, and let's kind of expand what we did before. It's the same thing. Out of the number list, now instead of 1 to 10, let's go 1 to 100. So we're going to run 100 different regressions here within this iteration. And now let's put in our command. So we're going to run a regression. So unemployment rate, try it again, sorry. Unemployment rate as a function of Fed funds, and it's going to be within the sample restrictions with the if command that we're going to do our iteration. So let's do that if t is greater than I. Okay. So the beginning of our regression is going to kind of float, right, with each iteration. And then the end is going to float as well. So if t is less than 100 plus I. So each regression is going to have 100 observations, and it's going to move, right, 1 month into the future, the beginning and the end of that 100 observation window, if you will. That's basically what we're doing. We're doing this progressive rolling regression across these 100 observation windows. And let's ramp this up with one more thing. So that's our regression statement, but we're still within the loop, right? Until I put that end bracket in, the loop is still operating. So let's store each of these regressions. ESTSTO, and let's call each of them regression 1 will be the first subsample, regression 2 will be the next, etc. So we can actually use that I placeholder within our naming convention for our regressions. Sorry, inverted commas. So it's reg underscore inverted commas I. Again, we can do that any way you want, but that's going to be a nice way to see what's happening. And then we hit enter, still within the loop. We could add more if we wanted to, but that's enough for us to play with right now. And let's hit our end bracket, and then we're off to the races. So we've got 100 different regressions here. I should have done less than or equal to. They each have 99 observations, but that's okay, right? And each of them have, right? Each regression has its own output, 99 observations, dot, 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 dot. But they're all a little bit different because those 99 observations are 1 month pushed forward in time. And then if we look over on the right-hand side, we've created these 100 recorded regression output placeholders, right? So now, this is kind of cool. Let's plot out those slope coefficients, right? And no one wants to go and look at each of those individually. So we're going to use the coef_plot command here. And we're going to be plotting the results of each of those saved outputs. So it's reg underscore star, and that convention in Stata, when you see that little star, it means everything that starts with reg underscore, whatever comes after it, whatever you put in that star, is going to be lumped in here. So I don't have to list all 100 of them out, but it's going to be equivalent to doing that. So I'm going to plot all of these, but I don't want the intercept. So I'm going to use the drop constant option. I also don't want the little color-coded key that comes along with this, because there's going to be 100 elements into it. So we use the no key option, and now we hit enter. It's going to take a second for my old Mac to generate this plot for us. So while we're waiting, how you guys doing? Oh, there it is. Okay, thank goodness. That's pretty cool, right? So each of these dots is a different regression coefficient for a slightly different sample of those 99 observations, right? So I believe starting at the top is going to be the first sample and then on down. So what we're looking for is these breaks, right? So we have this long period of stability. The relationship between federal funds rate and unemployment really didn't seem to change over those samples, and then things really change. So it's kind of a visual structural break test, basically, and a nice way to present your results. So that's pretty cool. Let's do a couple more real quick. So now let's iterate over variable names, which we can do exactly the same way with the same command, the foreach command. So this would come in handy in a situation not terribly unlike what we have here, where we have unemployment, for our example, dependent variable, and then we have 3 different interest rates as potential x variables. Imagine instead of 3, it was 300, right? Then you don't want to have to do it one at a time, but you might want to iterate over all the different options and compare regression results using interest rate 1 versus 2 versus 3, etc. So let's do something like this. For each x, and again, call it whatever you want, but here they're going to be x variables, so that might make sense, of not the number list, but the variable list. So of var list, and here the naming convention doesn't let us do anything real fancy here. We just click on them, so that's our list of possible things that we're going to iterate over. Here it's only 3, just to get a taste of it. Open bracket, and then we're going to run the regression of unemployment rate as a function of x. Each iteration is going to be a different x. Hit enter, get to the last line. Again, we could do more within the loop, but just to keep things moving here, that's enough. And then we do the end bracket, so that's the end of the program. And now what we see are our 3 regressions. So unemployment as a function of 3-month T-bill, as a function of the 10-year rate, as a function of the Fed funds rate. And again, we could plot those out. We could put them in a table. Lots of things we could do. A nice way to use that loop. Okay, one more. Since we do have time series data, oftentimes we're going to be running dynamic models, and it's often going to be uncertain how many lags of a given variable should be included. And it might be nice to have them all side by side to look at some comparisons. So let's iterate over that lag structure. We could do that easily here as well. So for each go back to our I convention, and we'll, let's go back to that list from 1 to 10. So for each I, of our number list 1 to 10, let's regress unemployment rate, and on the right-hand side is going to be the federal funds rate, but it's going to be different lag structures. So we can use the lag operator here. This is kind of a whole nother lesson as far as dynamic models, but just to see what we can do here. So it's the L dot is the first lag, L1, L2 dot is the second lag, L3 dot is the third lag, etc. And we want to start with the lag 0, so that's the current value, all the way up to the 10th lag. But instead of putting L0, 10, which would give me 1 regression with all 10 lags, we want it 0 and 1, 0, 1, 2, and 3, 0, 1, 2, 3, 4, etc. So we're going to go L0 slash I. So we're going to be iterating over that last lag dot Fed funds. And that's all we'll do within the loop. And now if all this works out, we should see exactly this. So what we've got here is the last regression here, which has the current and lag 1 through 10. The previous regression in the loop, the current value of Fed funds, and lags 1 through 9, etc. So we could have done within that loop, let's generate the information criterion, let's compare those results, lots of different things we could do. So hopefully that gives you a taste of what's possible within this loop structure in Stata. Lots more things we could do. Get creative with it. If you have any questions, put them down in the comments. I'll try to answer them. Otherwise, hope everyone is doing well, staying safe, and I'll see you guys next time.